Okay, so we're going to start off our year working with exponents, which will also take us into exponential equations, and we're also going to work with some geometric patterns. You'll notice today we're just going to do one part of law of exponents, which is going to involve multiplying. And then the first quiz we're going to have is going to come up on the either 11th or 16th, depending upon if you're A or B. And that will be covering those ideas that we're working on now. It's going to involve the law of exponents for multiplying and dividing, and then also the geometric patterns and some exponentials that we're going to talk about. So I want to start off with these two pages. When you glue them into your book, you're going to want them side by side. Oh, let me rephrase. When I glued them into my book, they look just like this. And then the next thing you're going to want to glue in your book will be on the next page. We're going to glue our Law of Exponents booklet. So if you want to take a second to glue that. So this is called, we're going to create Sierpinski's carpet. And what we're looking at is when you start off, we're kind of starting off with this big square right here. Okay, this would be our full square, and this is going to be just the outline of our square over here. Okay, I don't want to outline the whole thing, but that's what it would be. Okay, and we're going to take that big square, and we're going to break it up into we're going to break it up into ninths. Okay, so we're starting at our stage 0, which is not what we have here, would be we haven't done anything yet, okay? So the first stage we're looking at is we're going to break this up into ninths. So I'm interested in taking, at stage 1, I want to end up with a total of 9 squares. So what I want you to do is I want you to put your pencil on the right side, and I want you to count over 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and that's right here. And I want you to take your ruler and I want you to go ahead and draw a line through there. Okay? Then from that point, I want you to do it again. I want you to count over 9 more. 1, 2, 3, 4, 5, 6, 7, 8, 9. And from there, I want you to draw the same line. If you continue to count, you should end up with 9 again. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've broken it from left to right into thirds. So now we're going to do the same thing going from bottom to top. So if I start at the bottom, I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to go ahead and I'm going to draw that line. From there, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So now you'll see how I've turned this into those 9 squares that are in this scenario right here. This is stage number 1. Okay? So now that I've done that, you get to be a little creative. It's however you want. What we're going to do in stage number 1 is we're going to shade our center. Of our 9 squares, we're going to shade our center. So you can do this however you want. You could do it with one whole color. You could do it however you want. I'll give you 1 minute. Go. Okay, so now you'll notice in our table the next thing that it asks us for this exact same stage, stage 1, is, well, how many shaded squares did you have? Just in this step, how many squares did we shade? Well, we shaded that one big square in the center, correct? So now we're going to repeat this, okay? Now, we originally broke the big square into ninths. Now we're going to break each square, each littler square into ninths. So what I'd like for you to do is start off, and we're going to work on each square. Each square is a 9 by 9, so we're going to count 1, 2, 3, and I'm going to get a line right here. 1, 2, 3, and I'm going to get a line right here. Then from the left, I'll go 1, 2, 3, and I'm going to get a line right here. And 1, 2, 3, and I'm going to get a line right here. Now what you may notice is you could go ahead and extend this line all the way up. Okay, so now I want you to go through that same step and go ahead and break each of those squares into thirds. Okay, so if you'll notice, you'll see each one of my smaller squares has now been broken into thirds. So at this point, I want you to do the same thing. With each square, I want you to go ahead and somehow color in the middle of each of those. You got a couple minutes to do this, since there's a few more. Okay, so now let's go back over and let's answer some questions. So that would have been stage 2, where we had then taken this box right here. This would be our stage 2, right? Where we took it and now we broke our smaller boxes into even smaller boxes. So in stage 2, how many total squares did we end up with? Well, let's see. We had broken it into 9, and then we took each one of those 9. So let's write this out. We had broken it into 9, right? And then we took each one of those, and we broke it into 9, right? So that means I have 9 nines, right? Does that make sense? I had 9, and then I broke each one of those into 9. So basically you've got 9 times 9, don't you? Which would give me 81 squares that we've now broken it into. Next question it asks is, well, how many squares do you have shaded? Now keep in mind, it's asking how many do we have shaded in this current step. Well, in this current step, we shaded 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 shaded squares. Okay? So now I'm guessing you can bet, or you can figure out that now we're going to take each one of those smaller squares and we're going to break them up as well. We don't have to do quite as much work on those. Go ahead and pick the color that you want to go with to decorate them. And what you're looking for is each of the little squares that surround it. So for example, this right here represents one of my little squares, so all I'm going to do is shade the inside. This is a little square, so I'll shade the inside, I'll shade the inside, shade the inside, shade the inside, shade the inside, shade the inside. So basically you'll notice we are simply shading the middle of each one of those smaller squares that we had just broken it up into. So go ahead and take a second and finish shading all of those. So let's see, let's start off with how many squares we actually shaded in this session. You take a step back and you kind of notice you missed some. Okay, so in each square, for example, this was, that bigger square we made a while ago. I have 1, 2, 3, 4, 5, 6, 7, 8. Well, I've got 8 in each square, but then I've got what? 1, 2, 3, 4, 5, 6, 7, 8 of those. So would that mean that I shaded a total of 64 squares? You could take a second and count all those up if you want to. That's your call. The next thing we're interested in is now how many total squares did we have, okay? So let's see, the last one we had what, 81, and that was where we took our 9 bigger squares and turned them into 9 smaller squares, right? So now we have what, 81 squares, is that correct? And we're going to take those 81 squares and we're going to break each one of those into 9, which means we're going to have 81 groups of 9. So 81 times 9 would give me 729. And at this point, we're going to kind of stop with our carpet because it's going to start getting a little smaller. Can anybody guess what you would do next? If you looked at each square, you would take each square on the outside and you'd break it, and basically you'd end up with a dot in the center. That would be the part you'd decorate, okay? But anyway, what I'm looking for now is, let's talk about the pattern between the total squares. So I go from 9 to 81 and 81 to 729. If you'll notice, 9 times 9 is 81. 81 times 9 is 729. So to do this, I am actually multiplying by a constant ratio of 9. Okay? And then, so if I were to do that, 729, well, times 9 would be 6,561. Well, what if I don't know the term? Because this was in the first stage, the second stage, the third stage, and the fourth stage. But what if I wanted the 10th stage, or the 21st stage, or I don't even know what stage I'd want? Well, then you're talking about the nth term. And you'll notice right here, this one was 9 to the first power. This one was 9 squared. This one was 9 cubed. This one was 9 to the fourth power. So therefore, 9 on the nth term would simply be 9 to the nth power. And that's the way you could write that expression. That would allow you to find no matter how many stages you went through. So then let's talk about our shaded squares and how they're changing. If I look at those, this goes from 1 to 8, 8 to 64. Well, you may notice that these are multiplying by 8, okay? And that's going to be that common ratio or constant ratio, whichever term you want to use, okay? So then, if I kept up with that pattern, 64 times 8, well, that would be 512. Now, this one's a little different. Notice when I do this first one, if I did 8 to the 1, 8 to the first power, doesn't that give me 8? But the answer there is 1. But here, here's where I get actually 8. But notice if I did 2 minus 1, 2 minus 1, 8 to the first power, that's 8. So this would be 8, what, 3 minus 1, which would be 8 squared. This would be 8, 4 minus 1. So what you'll notice is the pattern is 8 to the term minus 1, okay? Because this up here would be 1 minus 1. And go ahead in your calculator, type in 8 to the 0, because 1 minus 1 is 0, and you'll notice you get an answer of 1. Anytime you raise something to the 0 power, you get an answer of 1. So what I want you to think back, do you remember anything about that arithmetic sequence? We talked about it in the beginning of the year. An arithmetic sequence. An arithmetic sequence has a common difference. Notice, not ratio, difference. In other words, you keep adding or subtracting the exact same thing. For example, here, I add 2, I add 2, I add 2, and I add 2. So the common difference for this one, equals 2. But then the one we're talking about now, it's a geometric. And a geometric is slightly different. You're not adding or subtracting the same thing over and over again. You're multiplying by the same thing over and over again. And it's called a common ratio, okay? You'll notice here, I'm multiplying by 2. I'm multiplying by 2. So here our common ratio is 2. Okay? So that's a little bit of an introduction to our geometric sequences. I think you kind of get the idea. You're talking about patterns, and you're looking for what are you multiplying by. So let's see if I can give you an example and see how you do. Let's say I gave you can you figure out what the common ratio is? Oh, I made a mistake there. My bad. This should be, there should be a 1 in there. There we go. Now it works. 1/3 times 3 is 1. 1 times 3 is 3. 3 times 3 is 9. 3 times 9 is 27, and so on. So our common ratio would be 3. Okay? Look at something like this. Can you figure out what the common ratio is for that? 2 times -2 is 4, times -2 is 8, times -2 is 16. So this one would be a common ratio of -2. And now that you kind of got into that habit of, I keep multiplying by the same thing over and over again, I'm ready to dive into these rules of exponents, because that's really what exponents are doing. They're telling you, hey, keep doing this over and over and over again. Let's multiply and multiply and multiply by it. Okay, so let's open up our book to that inner page right there, and let's see how this works. I'm interested in 2 squared, 2 to the 4th, okay? I want you to start off with numbers just so you can, numbers kind of get the idea. 2 squared is the same thing as 2 times 2. Well, 2 to the 4th power is 2 times 2 times 2 times 2. Do you agree? This would be what? This would actually be what? 2 times 2 times 2 times 2 times 2 times 2. Well, how many 2's am I multiplying there? A total of 6. So that's like 2 to the 6. Do you agree? Now, when you do 2 to the 6, I don't ever really want to leave these. When you have a number like this, you can go ahead and work that out. This one you could just plug into your calculator, which would be 2 to the 6th is 64. Doesn't always work out that way, but sometimes it will. So then let's look at this next one. I've got x cubed. So x cubed would be what? X times x times x. So that would be my first one of x cubed. And then I have times x all by itself to the 1st power. And you'll notice the last thing is y cubed. Well, y cubed would be 3 y's being multiplied by each other. So you notice this is just like that geometric sequence kind of. We keep multiplying by the same thing over and over and over again. So this would end up equaling what? I got how many x's? 1, 2, 3, 4. X to the 4th, and then I got 1, 2, 3. I got y cubed. So that's how that one would simplify. Have you figured out what this is actually doing? If there's a shortcut, is what I'm asking you. Have you found the shortcut yet? I'm not inclined to just give it to you. Looking at the next one, we've got x cubed and x squared. So x cubed would be 3x's, right? So x times x times x. And then I got x squared, which would be x times x, correct? And if you'll notice, we got a total of 5 x's. Well, if you haven't picked up on it yet, you could have gotten this by saying x cubed times x squared is the same thing as x, and take your exponents anytime you are multiplying like bases. And by like bases, this is a base. Okay? This is the exponent. If you are multiplying like bases, then all you do is add the exponents. And that would get you to x to the 5th power. So now looking at the next one, that means this would be x to the 1/3 plus 1/2. Okay? Now you got to see if you can remember how to do fractions, right? If I'm going to do fractions, I've got to what? Find a common denominator. I think 6 will work for both of these. 3 will go into 6 2 times, right? So 2 times 1 is 2. 2 goes into 6. 3 times 1 is 3, right? 2 6 equals 1/3. 1/2 equals 3 6. So we did it correct. And so I got x equals 2 6 plus 3 6. Remember, your denominator stays the same and add the top, and you got x to the 5 6. Okay? So what we're noticing at this point is rule for multiplying when you have exponents with the same base. So notice, I've got the same base of a. That means I take my exponents and I add them. So that would be a to the m times a to the n equals a to the m plus n. So let's practice a few. They get, of course, a little more complicated, so let's see how this works out. When you have multiple things, so you'll notice I got a constant, I got an x variable, I got a y variable, I got a constant x variable, y variable. Sometimes it's easiest to put your constants together, your x's together, and your y's together. So here I end up with 2 times 5. By the way, I would encourage you to be very careful. You're going to tell me this is silly, but it happens all the time. When we start multiplying our like bases and we're adding the exponents, what you're going to find is all of a sudden we're going to start adding this. In other words, instead of getting 2 times 5 is 10, we're going to say 2 plus 5 is 7. So be real careful, and I know you think that's funny, but I promise you it's going to happen. So my next thing would be x to the 5th times x to the 4th. They both have a like base. I got x's, so I'm going to do x 5 plus 4, which would give me x to the 9th. And then this would be y. Be very careful. There's a 1 there. I have a lot of people who just skip that. Don't do that, because 1 plus 2 is totally different than 0 plus 2. So this would be y cubed. Okay? So now let's try to split this out this time on our own. We're going to take our constants and we'll put them first. Then we'll take our y terms. So I've got y and I've got y squared. And then we'll take our z squared and our z. Keeping in mind that you don't have to do this, but sometimes it is helpful, especially when you're first getting started. So I end up with 3 times 5, which is 15. I got y times y squared, which will be y cubed. 1 plus 2 is 3. And then I got z squared plus z to the first power. This is going to be also z cubed. So this will be one for you to try. If you're watching the video, go ahead and pause it, try it, and then turn it back on, and I'll have the answer. So if you notice in this first one, I got 2 constants. I did 5 times 3, which gave me 15. And then I've got x to the 4th, the 9th, and the 1st. 4 plus 9 plus 1. That's the same thing as 14. So I ended up with 15x to the 14th power. Hope the notes help. If you have any problems with exponents, just come in, see me. Got tutoring every morning.